Hello guys, how are you today? So this is from term 3 week 7 physics CA. Some students collectively helped me in making this. Thank you so much for these students. So anyways, I'm just gonna explain this paper. Let's start with the first question. An object is dropped from rest in air from a height of 180 meters. It accelerates uniformly at 9 meters per second squared. How long does the object stay airborne? So they want what? They want how long, meaning they need the time. As we have what? We have the acceleration and we have the displacement, delta x. So if we have the displacement, delta x, and we need to find the time, and we have what? We have the acceleration. And pay attention, it's dropped from what? It's dropped from rest, meaning that v initial is equal to 0. And also x initial is equal to 0. Then we can say what? We can say that the equation we will need to use is what? Is UARM. Why? Well, first of all, because we have what? We have a constant acceleration because it accelerates uniformly, meaning it has a constant acceleration, so we will use UARM. Then what do we need to find? We need to find the time, but we have what? We have velocity initial, we have x initial, we have the displacement, and we have the acceleration. So you'll just write this equation 1/2 times acceleration times time squared plus velocity initial times time plus x initial, okay? So it will be what? It will be 1/2 times the acceleration, is equal to the displacement, right? So let's substitute now. So the displacement 180 is equal to 1/2 times 9 times the time squared plus velocity initial, which is 0 times the time, which is 0 plus 0. So just remove these, okay? Move this to the other side. So 180 times 2 is equal to 9t squared. Divide both sides by 9. So 180 times 2 over 9 is equal to what? It's equal to 40, right? So 40 is equal to what? It's equal to t squared. That means very simply, t is equal to radical 40. What is radical 40? Radical 40 is very simply, or approximately 6.3 seconds. So it stays airborne for how long? It stays airborne for 6.3 seconds. Move on to part 2. A car initially moving with a constant velocity. So now it has a constant velocity, meaning we will use URM, or uniform rectilinear motion. Okay, we have velocity initial, which is what? Which is 55 kilometers per hour, pulls out onto the highway and then accelerates. So now we have an acceleration of what? Of 1200 kilometers per hour squared. This is our acceleration in 15 seconds, and this is our time. So we have velocity initial, we have acceleration, we have time. They want to find the final velocity. So the equation we will use is what? Is velocity final is equal to what? Is equal to velocity initial plus acceleration times time. So velocity final is equal to 50 plus acceleration, which is 1200 kilometers per hour squared, times the time. But pay attention, the time is in seconds. We will need to change it to hours. How do you change from second to hours? Very simply, you will divide by 60 times 60. Why? Because if from seconds you divide by 61 time, you will get minutes, and then minutes you divide by 60 again, you will get what? You will get in hours. So in hours, 15 seconds is what? It is 1/240 hours. So very simply, it's 50 plus 1200 times 1/240. So 50 plus 1200 times 1/240. It will give us an answer of what? It will give us an answer of 55 kilometers per hour. We move on to the next one. A car is moving uniformly. Pay attention, the keyword is moving uniformly along a straight path at 12.5 meters per second. This is V initial. The driver applies the brakes, causing the car to decelerate. Deceleration uniformly and stop after 25 meters. This is what? This is the displacement. They want to find the magnitude of the car's acceleration. So it stops, meaning that V final is 0. So how can you find the acceleration? Having what? Having V initial, V final, and displacement. Very simply, you will apply the equation that V final squared minus V initial squared is equal to 2 times acceleration times displacement. All right? So V final in this case is what? Is 0. So 0 squared minus 12.5 squared is equal to 2 times 8 times 25. Okay? So 12.5 squared is this. So minus 156.25 is equal to 50 times acceleration. Divide both sides by 50, and you're gonna get what? You're gonna get that acceleration is equal to what? Is equal to minus 3.125. But they want what? They want the magnitude of the car's acceleration. So since we have it negative and they want the magnitude, we will put it in absolute value. So it will be absolute value of minus 3.125. So it will be 3.125 meter per second squared. We'll move on to question number 4. What does it say? The speedometer of a motorboat shows 10 kilometers per hour and 30 kilometers per hour at two positions, 500 meters apart. Assuming the motorboat is moving straight in a UARM, they want the acceleration of the boat. So we have what? We have V initial, V final, V displacement, and they want us to find what the acceleration. So here we'll have to use this equation, which is what? Which is V final squared minus V initial squared is equal to 2 times the acceleration times the displacement. So we have the displacement, which is 500, times acceleration times 2 is equal to V final squared, which is 30 squared, minus V initial squared, which was how much? My bad, which is 10 squared. So we will put it on the calculator. 300 squared minus 10 squared. Oops, no, 30 squared, my bad. 30 squared minus 10 squared, that's 800, okay? So 800 is equal to 2 times acceleration times 500. Ooh. Now, here is what we have to do, something important. We have 500 meters, we will need to change it to kilometers. To change it to kilometers, you will divide it by 1,000, so it will become 0.5. So now 800 is equal to 1 times the acceleration. So acceleration is equal to what? It's equal to 800, very simply, kilometer per hour squared. We move on to question number 5. What does it say? It says the total displacement of the train is what? Is 1350. So how did they find it? Very simply, because it's a velocity time graph, they found the area. So finding the area is the same as finding the displacement. Okay? So let's find the area together. Very simply, it's a trapezium, right? So trapezium, its area. So trapezium area. Okay? The trapezium, its area is what? Its area is base 1 plus base 2 times the height over 2. So it's base 1. Base 1 is this base over here. So 60 minus 30, which is what? Which is 30. Plus base 2, which is from 0 to 120, which is 120. Times the height, which is 18. Divided by 2, so you'll put it on the calculator. 30 plus 120 times 18 divided by 2. It will give us what? It will give us 1350. Now, we'll move to part 6, question 6. They want the displacement in time interval 0 seconds, 5 seconds. So, displacement in time interval 0 seconds, which is here, 5 seconds, which is here. So here, same thing, it's a velocity time graph and you will need to find the displacement. So we need to find the area, right? So we're gonna find the area, but of the specific points from 0 till 5. So this shape is what? This shape is a trapezium, right? Okay, so we need to apply the equation of the trapezium. So base 1 plus base 2 times the height, the height over 2, صح? So what's base 1 in this case? Base 1 is this over here, so 5. Plus base 2, which is this over here, this is what? 15. Times the height. The height in this case, you will take it like this, which is 5 over 2. Put it on your calculator and you will get 50 as an answer. We'll move on to question number 7. They said the distance covered by the particle. How do we find the distance covered by the particle knowing it's a velocity time graph? Very simply, what you're going to do is you're going to find the area of the trapezium. So remember, area of the trapezium is base 1 plus base 2 times the height over 2, right? So I don't know if this is too clear, right? So I'm gonna say this is 1.5. This is 6, right? And the total is 11. So base 1 is 11, let's say. Plus base 2, which is 6 minus 1.5, so that's 4.5. Times the height. What's the height? The height is almost 25 divided by 2. Let's see if we will get the same answer. I'm not sure even. Times 25 divided by 2. You're supposed to get what? I got 193.75. I think it's wrong. Hold on. 187.5. Okay, so in that case, I believe they did not take it as 1.5, they took it as 2. Just think it's 2 and 6. So this would be then what? This would be 4. So it would remain 11 plus 4 instead of 4.5. Okay, so 11 plus 4 times the height, which is 25, over 2, you will get what? You will get 187.5. Now, a police car accelerates from rest, meaning that V initial equals 0, x initial equals 0 at a rate of 2 meters per second squared. This is acceleration over a distance of 100 meters. Okay, the final speed of the car. So they want to find what? V final. So we have the displacement, the acceleration, and V initial. They want to find V final. You will apply the equation V final squared minus V initial squared is equal to 2 times acceleration times displacement. So displacement is 100 times acceleration, which is 2 times 2, is equal to V initial squared, which is 0 squared, minus V final squared. So basically, V final squared is equal to 400. So you do radical both sides, and you will get that V final is equal to 20 meters per second. Okay? Okay, so we move on to question number 9. What does it say? It says a body moving along a straight line at 40 meters per second squared. This is the acceleration. Undergoes a deceleration of 4 meters per second squared. This is acceleration initial, acceleration final. What would be the distance traveled by the body in 10 seconds? So we have what? We have the time. We have acceleration initial and acceleration final. They want what? The distance traveled by the body in 10 seconds. So honestly, this question makes no sense to me. Question 9 makes no sense to me unless this is supposed to be velocity. Because if this is supposed to be velocity, then it makes sense, but otherwise it really doesn't make sense. So please check this out with your teacher, because I really don't know how to solve it. Number 10, a particle initially at x equals 3 meters. So this is what this is, x initial. Moves uniformly towards the origin. So if it's moving towards the origin, that means it's going back at a speed of 2 meters per second. So this is V initial. The position of the particle at time 3 seconds. So we have what? We have x final. We need to find it. Okay. We have x initial. So we can say x final is equal to x initial plus velocity times time. So it will be x initial, which is 3, plus velocity, which is 2, times what? Times the time, which is 3 seconds. But because it's going back to the origin, the velocity is it's negative. Okay. So 3 plus minus 2 times 3. Okay, my bad. Okay, I think this is 5 seconds. Sorry, I cannot read the handwriting because I'm half asleep. So 5 seconds. If it is 5 seconds, then it's going to be 3 plus minus 2 times 5, which will give us an answer of minus 7. A motorcycle initially moving at velocity initial 30 kilometers per hour accelerates uniformly through a distance of 2 kilometers. Okay, reaching a velocity of what? Okay, let me just again. We have velocity initial here, accelerates uniformly through a distance. This is the displacement. Reaching a velocity final, this. They want what? The time required to cover the distance d in the prescribed motion. Okay, so very simply, we will apply this equation. There's an equation, it's like this. Velocity initial plus velocity final over 2 multiplied by the time is equal to what? To the displacement. So if we need to find the time, that means the displacement over velocity initial plus velocity final over 2 is equal to the time. Okay, so the displacement is 2 kilometers over velocity initial, which is 30, plus velocity final, which is 50 over 2. This will give us an answer of what? This will give us an answer of 1 over 20. So this is in hours, 1 over 20. So to change it from hours to minutes, you will multiply by 60 to get what? To get 3 minutes. Question number 12. A particle initially moving away from the origin at 3 meters per second is slowing down at the rate, okay. Initially moving away from the origin at 3 meters per second. The initial is slowing down at a rate of 2 meters per second squared. So this is what? This is the acceleration. They want the velocity of the particle at time 5 seconds. So we have velocity initial, acceleration, and we have the time. We need to find V final. So V final is equal to V initial plus acceleration times time. So V final is equal to 3 plus acceleration, which is what? Which is 2 times what? Times the time, which is 5. However, it is what? It is slowing down, so the acceleration is going to be negative. So it's going to be 3 plus minus 2 times 5, which is what? Which is minus 7 meters per second. Number 13, a car is uniformly accelerating along a straight road. Its speed increases from 10 meters per second to 30 meters per second in 5 seconds. Modeling the car as a particle, the distance traveled during this duration. So we have what? We have it's uniformly accelerating, so we will use UARM. Its speed increases from what? From 10 meters per second, this is V initial, to 30 meters per second, V final. Okay? In 5 seconds, this is the time. So they want the distance traveled during this duration. So here we need to find what? We need to find the displacement. We have what? We have velocity final, velocity initial, and the time. So you'll apply the equation velocity final plus velocity initial over 2 times the time. So delta x is equal to what? Velocity final 30 plus initial 10 over 2 times 5. So delta x is equal to what? It's equal to 20 times 5, which is what? Which is 100 meters. So the answer is supposed to be 100 meters. I think I will stop at question number 14. I might continue the rest tomorrow. A particle is confined to move along a straight line. The particle is initially at x minus 5 meters. This is what? This is x initial, moving away from the origin with an instantaneous speed of 2 meters per second. So this is the velocity. And the constant acceleration of this. So this is what? This is the acceleration. They want the position of the particle at time 3 seconds. So we have acceleration, x initial, velocity initial, and the time. So you'll apply which equation? Because also it is what? A constant acceleration, you will apply UARM. Right, so here in UARM, you will use 1 over 2 times acceleration times time squared, plus velocity initial times time, plus what? Plus x initial. So x initial in this case is minus 5, plus velocity, because it's moving away from the origin, I think this is supposed to be minus 2 meters per second. So minus 2 times the time, which is 3, okay? Plus 1 over 2 times the acceleration, which is 1, times the time, so 3 squared. Put it on the calculator, you will get minus 6.5. I think they rounded minus 6.5 to minus 6, I'm not sure. Now the rest, I think I'll do them tomorrow, but I will do a video about the equations.